which document the earthquakes daily. Normally we have about 3 to 4 Richter, but earthquakes with the intensity of 6 Richter or above is rare, but it's estimated that huge amount of fatalities may be occurred if we have such an earthquake. Therefore, we try to focus on this topic in our Center of Excellence in Disaster Management. But the important point is that there are some parameters, including the intensity of the earthquake, the time, duration, position, and we try to reduce the uncertainty of estimating this vulnerability assessment. The presentation is based on the smart data fusion techniques for vulnerability assessment, physical vulnerability assessment in Tehran. As a quote from Professor Zadeh from ISSPQ 2007, there is a symposium on spatial data accuracy, international symposium. Professor Zadeh mentioned that information is the lifeblood of the society, and decisions are based on this information. But mostly we are dealing with some imperfect data, uncertain data, data which are partially true, and based on these conflicting results, we need some models to estimate the information for the decision making. There are different methodologies for spatial data fusion, including probability theory, possibility, fuzzy logic, depth spatial rough set theory, and in this talk, I would like to explain about these methodologies and how they are implemented in vulnerability assessment in Tehran. There is another quote by Professor Shi from a paper published in Nature 2007 that geotechnology, along with nanotechnology and biotechnology, are the most affecting technology in the world, because the geotechnology are the base for other technology in order to have spatial correlation and association with each other. There are some challenges identified by OGC, which are including the protection and security, e-government, risk management, earth system science, defense and intelligence, real property and land information, sustainable development, and mobile enterprise. Today we are talking about risk management and earth system science. There is a cycle of disaster management in preparation, response, recovery, and mitigation. And we have worked mostly on response part of the disaster management cycle and preparation. Here you can see there are several known and unknown faults in Tehran, mostly in the north of Tehran, which is the North Tehran fault, Moshal fault, and Ray faults. And Tehran has been affected by this activation of these faults. And if each and every of these faults activated, then there would be different impact on the earthquake fatalities. As I mentioned, we have about 150 years for the period of return, temporal period of return of the big earthquakes in Tehran. And we have a number of aged buildings. There are some problems with standards in some parts of Tehran and other cities. And populations, the growth of population have also increased the risk of this problem. In terms of disasters, there are different disasters: social, economical, industrial, natural, and administrative. We are concentrated on natural disaster and specifically on earthquake. In disaster management cycles, the response and relief part is concentrated in this part, and we are going to produce the damage maps, the possibility of this in order to assist the decision makers to have a better estimate for the recovery and response. For seismic vulnerability assessment, we are dealing with a multi-criteria decision-making problem because of the different factors, human factors, physical, social, and systematic factors. The investigation has been done so far on the disaster management. There have been some models for vulnerability assessment, some quality assessment methodology have been developed, some software have been developed, and GIS have been used in the earthquake assessment. We are going to have some estimate on the physical assessment and sensitivity analysis and uncertainty in this respect. Different models which have been produced so far in the multi-criteria assessment, decision making, integration of different methods with GIS based on the full integration, partial integration, or loose coupling or tight coupling approaches. Different criteria have been used, for example, human vulnerability assessment or physical vulnerability assessment, and different multi-criteria approaches and the different data have been compared. For example, AHB, fuzzy logic approach, SVA, integrated models, R1 facilities, 3D models, systematic vulnerability assessment for the social vulnerability based on the average income of the people or housing ownership, and also physical parameters and systematic parameters, which including the driving time to hospitals, walking time to hospitals. The software developed, the most important one, for example, like Azus software, developed by Federal Emergency Management Agency in US, and there are a couple of more softwares like Selena, which use the Google Earth and differential SVA. For the quality assessment, a number of models like TOPSIS approach have been developed. In Azus model have been used and accuracy assessment with different data, including remote sensing data. In Tehran, we have started our first work 15 years ago on the use of fuzzy logic and AHP approach in order to implement, develop a vulnerability assessment map, which I explained over here. Another study we have done on institutionalistic fuzzy because of some limitations of fuzzy logic theory, which I'm discussing at this presentation. And we have also used TOPSIS approach. Neural network have been implemented, and also we have used the group decision making based on rough set theory and neuronal computing. The problem, as I mentioned, that we have about 12 major earthquakes in the 20th century in Iran. More than 70% of Iranian cities are under earthquake risk. 126,000 people have been died in the 20th century due to earthquake. More than 40,000 people have been killed in 1993 root bar earthquake in the north of Iran. Earthquake left 500,000 persons homeless, and 100,000 houses were destroyed. 3 cities and 700 villages are ruined, and the construction cost estimated to be 2.8 billion. We have this earthquake has got 7.2% of the Iranian GDP, and also 30,000 people have died in Bam earthquake, and we are going to have some estimate of uncertainty of this earthquake loss in terms of spatial data and spatial data fusion techniques. So Iran is located in the seismically active areas in the world, in alpine mountain systems, and production of seismic vulnerability could assist the decision makers in the decision making process. And seismic vulnerability is a multidisciplinary problem. Therefore, we need to have some multi-criteria decision making and the methodology to evaluate this decision making process. And there are different influencing factors. In this study, we try to consider mostly the spatial factors, spatially related factors, or physical factors. This is the Iran Seismic Vulnerability Map produced by International Seismology and Earthquake Engineering Institute of Iran. As can be seen in this figure, the higher the higher the color is, the more risk of the earthquake intensity, and it says most part of Iran are under earthquake risk. So GIS is going to support this special decision making process, but we are dealing with different sort of uncertainty which comes through different data have been used and different methodology to integrate this data. And as we know, in uncertainty management, it's impossible to use to make use of the bad data to get good results. It's impossible. But if you are going to use the good data, it's unlikely that you can be sure that you get good results. It depends on the models which you use for your integration. Therefore, the uncertainty which are dealing in this system is based on the spatial data quality and uncertainty of the models to integrate these data. These natural disasters are also one of these decision-making process. In this image, you can see more clearly that the position of North Tehran faults, Moshal faults, and Ray faults, South and North Ray faults, and there are some unknown other faults in the Tehran. And Tehran will be affected by all these faults. We started our work 15 years ago. At that time, Tehran has about 1.5 million apartments, 7 million population, and 3,000 statistical units. At the moment, we have about 10 million population during the daytime and 8 million population during the nighttime. And the statistical units have been more detailed. We have about 6,000 statistical units at the moment. For this, in order to have the risk map, we have two: vulnerability map and hazard map. Vulnerability is mostly related to the physical properties. For example, the buildings, the height of buildings, number of floors, the quality of the building, and also the slope. And the hazard is related mostly to the geological characteristics of the soil, and both of them have been used in risk management, but we concentrated in this research on our vulnerability map. Our first study started with a fuzzy AHP DSS evaluation of cities against earthquake. Fuzzy logic is the methodology developed by Professor Lotfizadeh, an Iranian professor who first initiated this methodology to give some estimate of uncertainty if we can allocate some membership functions between 0 to 1 to any possible event. This methodology has been integrated with AHP in order to have some criteria weighting between 1 to 9, and then we are going to use this for our uncertainty assessment. The quality of the decision is very important for this process, and a DSS which have been developed in this system is to give some errors in the data and to give some results, and also use different weights for different data used in this process. In this disaster management process, we are considering a number of criteria, and these criteria are being used in the decision-making process, and we are going to estimate the uncertainty in this process based on this data and the fusions. So we have different solutions for uncertainty modeling. One way is to ignore uncertainty and consider if there is no uncertainty in the data and the models, what we can have, but absolutely these terms will not happen in practice, in reality, because we are always dealing with some sort of uncertainty. But the evaluation and documentation of this uncertainty is very important, and the effect of uncertainty on the decision-making process. In the AHP analytical hierarchical process is the methodology developed by Professor Soati, and for the comparison of the pairwise comparison of different criteria. It's based on the simplifying the problems, defining different scenarios, defining effective factors, and structuring the categories and applying the assumptions for the sensitivity and consistency analysis. In uncertainty management, we have tried to use these two methods, fuzzy and AHP, although a number of criticisms have been come with respect to the fusion of different data fusion techniques, because some people believe that if we fuzzify a model, we introduce some sort of uncertainty in the model, and if we use the AHP or another data fusion technique, we further introduce uncertainty, but we don't know really whether these two will be converged or not. But this is the methodology which have been tested over here in order to characterize the method and derives the some crisp information out of the inconsistent uncertainties. The methodology over here, we have used a pairwise comparison of we have developed a comparison matrix, and then give some weights to this criteria and assume some triangular membership functions as the weight of the, in this we have used triangular function for classification of the our problem. And based on this different criteria of equal importance, weak importance, up to extreme importance, we will assign or allocate numbers between 1 to 9 in the AHP comparison process. And in our case study, we try to have estimate the earthquake fatalities and the social risk based on human and physical vulnerability. The criteria which have been considered is the building floors between 1 to 3, 4 to 15 and more. Buildings structure, which is the quality of the buildings. Buildings age, because the first regulation of the building construction in Iran has been approved in 1966, and we have considered this year as the start of our historical data. And then between 66, the next regulation has been approved in 1975. Based on this, we divided the different quality of the buildings. And population. So here are the different factors which is based on the physical arrangement, building, number of stories, structures, age, and then residence population, and divided into different classes in order to have some estimate of physical and human vulnerability assessment. Here is the matrix, comparison matrix, and we consider 3 different scenarios. For each scenario, we have given some weighting in the AHP process. And for after normalizing the weights, we have different weight for each scenario. And the fuzzy AHP weights have been calculated. For integration of the data, we have considered 25 by 25 meter cell size. And in this research, we assume that only the rainfall in the southern west of Tehran is activated. Although in continuation of this research, we have considered the effect of other faults as well. Based on the activation of this rainfall, we are assuming that if we have an earthquake with intensity of about 6 Richter or above, this is the distribution of the possible fatalities using fuzzy AHP approach, and this result have been confirmed by the results produced by JICA Japan International Academic Program, because they have also done some studies in earthquake assessment in Tehran. For this data, we have considered the end operation in overlay assessment. The average accuracy for classification is 0.8, minimum accuracy 0.79, and the maximum accuracy is 89%, considering some training data introduced and some test data in this modeling. And the modeling is based on the Verigine 9089 equations for the error assessment in an operation. Verigine published this formula in the, because we have a NCGIA, National Center for Geography and Information Analysis. It was the biggest research center in GIS. It is established in 1988 in the US with the collaboration of University of Maine, Department of Civil Engineering, University of Buffalo, and University of California and Santa Barbara, Department of Geography. And they have worked on different initiatives, including 12 initiatives, and uncertainty was among the first initiatives in this research center. The other, in continuation of this research, we try to estimate the uncertainty of the vulnerability map produced. We are going to have some specific and location-based uncertainty for every statistical units presented in the previous work. We have used Monte Carlo simulation in this uncertainty assessment and quasi-logic AHP approach in order to have, in order to produce the vulnerability, earthquake vulnerability map and also earthquake vulnerability uncertainty map, both of them in order to complete. In this research, we have also considered population statistics, building information, maps, DTM satellite image in order to estimate the population, and also Monte Carlo simulation have been used because there are two approaches in order to estimate the uncertainty. One approach is analytical approach, and another one is simulation. Monte Carlo is one of the simulation approaches for uncertainty assessment. In this model, we have a dependent variable y based on some joint of distribution of different variables x and the functional relation, and based on this we are going to introduce some errors in the data and estimate the effective parameter on the functions. For uncertainty and risk management, we prepared, assuming the prior knowledge, no prior knowledge is required for the simulation approach, and uncertainty on the spatial data based on omitting all reference to data or attracting forms of description to the output, and also showing some samples of the range of maps, possible output. As I mentioned, there are some different approaches: analytical, simulation, experimental, and uncertainty descriptor, and all of these approaches have some advantages and disadvantages, which I'm not going to the detail of them because of the time. This is the Monte Carlo approach. Monte Carlo approach have been used in GIS for a long time in order to have some estimate of the different parameters and the uncertainty different parameters and its effect on the output. In order to apply this method, we have to divide different ranges of the image of the data, replace the observed data with a set of random variables. Randomly, we change the input data, apply a sequence of GIS operations, and prepare some realization of the results and compute some statistics, summary statistics. In this is the flowchart of this research. We have building and population, determination of uncertainty of the input variables, determination of the number of repetitive states, and also applying a sampling method, LHS, calculation of the mean the statistical parameters, mean and standard deviation, and repeating until reaching the specific accuracy for the overlay analysis. This is the Latin hypercube sampling in order to divide the whole range of data into, for example, 5 classes. In uncertainty modeling, we estimate the mean and standard deviation and the trends of prediction of the vulnerability map in Tehran have been calculated based on this multi-criteria and Monte Carlo simulation. This is the process of estimating seismic vulnerability based on the building floors, number of floors, age of the building, and also based on the population. This is the result of uncertainty map. It means that for the measure of human uncertainty produced in the previous research, in each statistical units of Tehran, we can give some estimate of accuracy for the produced map. For this implementation, we calculated different samples. We applied different samples of the data, and based on this repetition times, we got some estimate of variance. So in the previous research, we have used the fuzzy logic, but fuzzy logic has some limitations. The first limitation is that when we have the membership function as 0.5, then we cannot decide to allocate the pixel to either of the classes. It is one problem. Another problem is we have to assign the membership function as a crisp measure, and this is another issue. In institutionistic fuzzy, developed by Atanasov in mathematics, the idea is that we have one membership function and one non-membership function, and the uncertainty is based on these membership and non-membership plus one, the third factor, which is estimated in this process. We have used institutionistic fuzzy sets for vulnerability assessment of Tehran based on the optimistic and pessimistic results. And in this research, we compared the ideal points and the accumulated simple weighted average for the institutionistic fuzzy method. Here we have used the physical vulnerability plus human vulnerability. In physical vulnerability, we have the intensity of the earthquake, percentage of weak building, instead of quality of building, percentage of more than 4-story building, about the high percentage of the building built before 1966, about the age of building, and after that up to 88. And for human vulnerability, we are considering the physical high physical vulnerability, which is the result of this process, plus the population, percentage of child population, and also high percentage of old population. The institutionistic fuzzy approach is based on the idea that if we have a set X, then we have some estimate of the membership functions, and also we have some estimate of non-membership functions. And this, if we consider the p-value over here, p, which is an uncertainty, is related to the 1 minus membership function minus non-membership functions. And the p and the measure of uncertainty is between 0 to 1, the same as the fuzzy logic. In order to implement the institutionistic fuzzy process, we have to select all possible pairs of the criteria considered, preparing a set of pairs of the criteria based on the maximum preference with respect to each other, determining the membership and non-membership values for the pairs, separation and grouping the membership values of, for all of the pairs, calculate the mean value for the groups, determine the membership and non-membership degree, and weighting them, and ranking the criteria. The criteria have been considered in this research was high intensity earthquake, high percentage of big buildings, high percentage of more than 4-story building, high percentage of buildings built before 66, percentage of buildings between 66 and 88, high slope, high level of the physical vulnerability, high level of population, high percentage of child population and old population, elderly. In this table, you see based on the parameters, 9 parameters considered. For each of them, we have one membership value and one non-membership value. The summation of these two is not necessarily 1 because we have some uncertainty in both membership and non-membership value. These two tables are calculated based on the expert view, or it could be through different number of sampling. But as we may not be able to have infinite number of sampling, therefore we have used the expert views on this analysis. And experts always have some conflict with each other. There are different experts in different criteria, and therefore uncertainty will be introduced in the experts' views. So we have two tables of membership value and non-membership values for each parameter, which is the first row for each factor. For example, for A, all the membership values are here, and non-membership values are in the second table. And the last column will have the average of this membership value for each criteria, and average of non-membership values for each criteria will be calculated. And we will use one normalization functions based on the two threshold, and we weighted the membership value and non-membership values. And based on this non-preference based normalized base, preference based normalized base for each criteria will be calculated. This research has been calculated based on the day scenario, night scenario, because there are different possibilities of earthquake fatalities during the day and night, and also during the education time period, and also during the summer. There are different effects. And this is the optimistic and pessimistic map based on the accumulated simple weighted average of intuitionistic quasi approach. It means that in pessimistic, we have more possibility of, if North Tehran fault is calculated, which is here, more fatalities will be available in Tehran, because in this state, this is the central part of Tehran, we have a number of aged buildings and more population. In north of Tehran, we have stronger buildings and less population, but the effect of these faults will be more in the central part and also southern part of Tehran. There are two thresholds for pessimistic and optimistic approach. And based on the ideal point, the distance between the ideal points, we have less number of fatalities estimated to have in Tehran. The other approach, the other case study has been done with Dempster-Shopper theory. As you know, there are two classes of uncertainty. One is based on the probability theory, and another one is based on positive logic theory. Dempster-Shopper, provided by two scientists, Dempster and Schaefer, they have worked separately during 1967, and then this theory has been combined based on, and it's called Dempster-Shopper theory. It's an extension of Bayesian theory, which gives that for some estimation of uncertainty, we can have a lower threshold and upper threshold based on the evidence which can be achieved. Then we can assign the possible or belief map and possibility map, plausibility map, and we can also estimate the uncertainty based on the belief and plausibility maps. For selecting this, this approach is also based on the expert views. And for uncertainty, we have used DST, depth repair theory, and our AHP approach integrated. The objective is to produce a seismic vulnerability map based on the earthquake intensity, mean slope, deep building less than 5 floors, deep buildings having equal or more than 5, the buildings constructed before 66 and during the 6 to 88, and for this we have considered the Bayesian formula in order to normalize the DST approach. The criteria is based on selecting the influential criteria in multi-criteria decision-making problem, weighting the criteria by Dempsey rule of combination, and also integrating the data based on the DST-AHP approach. In order to calculate the weighted criteria, all the criteria have been normalized using DST approach, and the some estimate of ambiguity is also introduced in this estimation. For integration of DST AHP, there are these two methods are there are some differences, and they allow us to compare the different groups of alternatives provided by the experts, and then there's a rule of combination will be in order to aggregate this criteria, and we can divide different choices and group the blocks into some vulnerability classes. We have divided Tehran into 5 vulnerability classes, including very low vulnerable areas, low, moderate, high, very high, and vulnerable grades. And based on the Bayesian combination groups, we have some criteria weights, number of group blocks, and their importance, and they will normalize in this formula and give some class of the earthquake intensity in a slope, different factors. And then these evidences will be aggregated, the evidences which are given by the experts as the first evidence, they will combine, and then we'll get aggregated evidence from the expert. This is the map which shows the physical seismic vulnerability map of Tehran using the DST-AHP approach, considering this North Tehran fault activation. Another approach introduced by Professor Zadeh and a number of colleagues. The first paper published in 1979, and then Zadeh further worked on this and give another extension on 1997. Professor Lin and Professor Yao have developed this idea, which is based on granular computing. This method is based on if we divide and conquer the whole set, and then try to estimate some lower and upper approximation of the uncertainty, and estimate some parameters for each building blocks. This is the idea of granular computing, and we are going to use this in vulnerability assessment in Tehran. The problem is that Tehran is located on 15 active faults. During the last 172 years, Tehran has not huge earthquakes. Some statistics show that the return period is 158, with 7 Richter is expected in Tehran. This is as I mentioned, it's a multi-criteria approach. And the risk assessment, we have a number of physical seismic risks based on the residents, buildings, open spaces, schools, hospitals, and human aspect. In order to respond to earthquake disasters, motivation is that it is a very important issue in Tehran. For production of seismic vulnerability map as a multi-criteria problem, we need to have some expert knowledge. Because, as I mentioned, we either should choose a definite number of samples, which is impossible economically and technically. Therefore, we can rely on different experts' views in order to have their views on the existing uncertainty, and then making decisions based on this. And we can have some rule mining approach. This is one of the ideas in the data mining approach in order to extract the rules based on different experts' evidences and different experts' views. The objective is to have some physical seismic modularity map based on the criteria I mentioned before. The assumption is that every physical quality building, age of building, number of stores, the slope and intensity are the main factors, and the depth of groundwater is also considered in this research, because the level of groundwater in Tehran is high. It means that if we have the upper height for the groundwater, the soil liquidity is more, and the effect of earthquake may be increased. In this study, we have used different experts' decisions. Based on that, we have collected large number of data sets, and we have done unaligned stratified random sampling, because we have different approaches for sampling. We have considered random sampling, but this random sampling have been stratified in order to have the samples in different parts of the data, and we try to use this unaligned in order to have this random data in different directions, and then induce some rules based on the granular network, and then apply these rules in order to generalize the result to the whole city. There are a number of challenges. One of the challenges is partitioning approach, because we have to divide the whole data set into some partitions. The number of partitions, the accuracy of partition, spatial distribution are important. We have to use some pairwise comparisons of the structure. We have used the entropy approach, because the entropy is the aggregation of uncertainty, and we have to select a methodology in order to reduce the entropy or reduce the uncertainty, and then classify different attributes based on this idea. So granular computing is provided by Professor Zadeh, as the information granularity involves the partition of a class into objects of granules. Each granule has a clump of objects which are bound together by indistinguishability, similarity, or functionality. It means that when we divide the whole data set into some parts, divide the whole to the part, these partitions should be distinguishable with each other. They should not be confused or overlap. They should not have similarity with each other, because the best way of classification is to maximize the between class heterogeneity, and also for the delineation of the boundaries, we should have the minimum maximum class heterogeneity, and for the classification of the class, we have maximum number of homogeneity in the class. GRC is a label of the family of theory, which is based on the groups, classes, and clusters of the universe. And it is a subset of universe is regarded to the primitive motion of granular computing, different levels of the relations and hierarchy of operations required, and the higher level of the data will be decomposed into the smaller level, and there should be, when we go further down, we should have the detailed description of any granules. For this, we can calculate some descriptions based on the some evidence and some rules, because we have some evidence as a field, and then some results we get as a casing, and we are going to find out the relationship between evidences as the input data and the output data. Based on the evidences, we create an information table. This information table is based on the criteria introduced and also the idea of the experts in respect to the each criteria and their importance in the physical vulnerability assessment. This information table is based on the U, which is the universe of the object, the whole set of objects, and then attribute AT is the attribute allocated to each partition. L is a language defined for the extraction of the mathematics. V is the non-empty value of each attribute, and U to V, which is the functions which relate, which give assign every value to each particular object. In this information table, for example, these are some statistical units in Tehran, and then for each criteria which have been asked by the experts, for example, building the building with more than 4 floors, building between 66 88, or for example less than 4 floors, a slope. The experts will give some numbers, and these numbers are based on the vulnerability classes. For example, very low vulnerability, low vulnerability. We have some estimates in order to assess the general computing. One of them is the generality approach. Generality means the division of MP by U, which is universe. It means that the number of the evidences which have support by the experts divided by the number of union, it means the generality of the results. If the rules have more generality, if they are more applicable to the data, for example, in this generality means that for each object, each statistical units, based on the slope, number of, for example, law and intensity, the number of pixels allocated to each statistical units will give some measures, and this class divided by the universe is the generality of the result. For example, if we select some points which we are looking at the buildings constructed in low slope areas. In low slope areas, we have only U4 where the slope is low. And therefore, the generality of this low slope is 0.25%. 1 unit based on the, for example, 1 unit divided by 5.2. Another measure of granular computing is based on confidence. Confidence is the measure in order to have some input data, some evidences, and we are going to estimate how these evidences conclude the final results. This confidence is, or absolute support, is based on the number of the KC membership functions up to the U, and the coverage is based on the number of M and KC both as an AND into the number of KC, which is the coverage of the results. For example, in this table, if we go to the, for example, a slope of the medium, we have only U1 and U5, which are both in class number 3, vulnerability assessment. So U1 and U5 are the two main class in respect to the slope medium. And then you can calculate the different measures of probability distribution and condition entropy and we are going to search the granules which have the minimum granularity, which means minimum uncertainty. So in this, it's a partition process and repetitive process based on different coverage. And in this table, as you see here, are the different criteria and different statistical units, and the experts given some allocated vulnerability classes. So here we can calculate the confidence and coverage, and we can have some decision tree classes. In this decision tree, we have a universe of evidence, all the objects, all the statistical units, for example, in the class, and then a differentiation of different classes is based on the this node of this tree and the leaf of this tree, and based on this, we can allocate the membership functions based on the confidence and the coverage and entropy. When we calculated the entropy 0, we can make sure that selecting these routes have minimum uncertainty. Although I agree that in reality we don't have 0 entropy, but in mathematics we may assume that we can have. We hope to reach this 0 uncertainty. So GRC methodology for seismic vulnerability assessment have been used with this criteria and normalized criteria. We calculated the results with the JICA data based on 113 samples in urban areas out of 3,000 statistical units in Tehran. 50 samples have been calculated based on the groundwater level. And those samples have been aggregated with the granular network, and this is the vulnerability map of Tehran, physical vulnerability map of Tehran, considering the North Tehran fault activation. This is the level of groundwater in Tehran. There are 3 districts in south of Tehran, and you see the situation of the groundwater. And we have considered the impact of association between the groundwater and the electric vulnerability. You see that in these areas we have more number of vulnerability classes, where we have more risk to the water ground. Considering the depth of the underground water, we have different scenarios. And we have considered calculated the accuracy assessment of this approach between 70 to 69, considering the whole Tehran and the part of the data we have considered. We have used the overall accuracy for this approach based on the number of objects correctly classified and the number of objects that are incorrectly classified, which is the overall accuracy of this approach. But we are also working on to make different classification accuracy assessment. Another study has been done in order to fuse dense shaper and granular computing. We further complicated the fusion approach in order to have this assessment based on the integration of DSP and GRC. Dense shaper theory, as I mentioned, is an alternative approach on probability theory in order to handle the uncertainty given by Dempster 68 and Shaper 76. The idea is to assign the allocation of the probability map to alternatives and then import the aspect of DSP based on the theory of the evidence. In Dempsey-Shaper theory, it gives this membership function between 0 to 1. M phi is 0 if it is empty set, and the sigma is 1 is the overall set. And we have a belief function, which is aggregation of the belief for all the evidences. And the plausibility is based on the, if we have some evidences which may have some overlap with the core data. And the principle is based on the rule of combination. It is the seismic information table. And the methodology is based on, we have got the 25 samples in different areas of Tehran using analyzed stratified sampling, using the same criteria, and then use the Bayesian functions in order to aggregate this combination rule of expert in the Shaper theory. For the methodology of the research, firstly we measure the entropy as the one measure of the neuronal computing, then absolute support, generality, and coverage, then select the attribute values which have the entropy of 0, then eliminate the priority of the set of the data with 0 entropy based on the maximum generality and maximum based on the maximum coverage. Choice of the samples of the area in the 0 entropy sections. If the 0 entropy sections are equal to the whole set of the data, then we can extract the rules. Otherwise, we consider the maximum coverage of the data and also then repeat this process in order to get the whole set of the non-zero entity equal to the whole set, and then it will be go to the extract the rules for rule mining approach. The result shows that neuronal tree, or which is a decision tree approach based on GRC, can reach 0 entropy or can go towards the 0 entropy approach, produce seismic vulnerability map, and then estimate the accuracy of this approach. This is the decision tree classes based on the whole universe, and the different classes separated by coverage, by generality, by entropy, in order to reach the classify each particular statistical units. This is the seismic vulnerability map of Tehran using this combination of GRC and BSD, considering no Tehran fault is activated. It shows that, as I mentioned, we have divided the data into 5 classes. 1 is the lowest vulnerability and 5 is the highest vulnerability. It means that most statistical units in Tehran have either high vulnerability or very high vulnerability. It means that less number of statistical units have very low vulnerability. So GRC DST results for Tehran shows that it's a new approach for physical vulnerability assessment, and it can be used for classification of rules, and also shows the expert views. Here we got some 60% accuracy in this approach, considering the conflicts between different experts. In another study, we have used fuzzy integral operators, OWA, for this vulnerability assessment. The objective is to use the Choquette and Sogino fuzzy integral operators, and also doing some error assessment in vulnerability assessment. In multi-criteria decision making, we have to have some alternatives, and for each alternative, we have some criteria. We got the views of expert and scoring the views, and ranking the results, and final decision making. And in all process of this data handling, we have specific uncertainties in different parts. In this multi-criteria approach, we'll give some preference to some alternatives, and we have used a number of experts, and we have used the voting approach. Every particular expert have given some evidence, some views, and the views which have the majority of votes will be considered. In this approach, we have a number of single expert and group decision making, because if the group decision making have the same idea, it will be converted, it will be equivalent to the single decision making. But each of them have got different values, different views. We have used different aggregation operators in this approach, Sojino operators. Some traditional operators have some inefficiency in alternatives, but quasi-integral operators can have some priorities based on Choquet and Sojino. Here we can have some overlap between decisions, and we try to minimize this overlap. We have used the game theory because it can be considered that each expert can give its view during a game, and then use this prediction of outcomes between cooperating games, introduce different economic values. We have used the shape index in game theory in order to assess the criteria. The criteria interaction based on the complements, redundancy, and independency of the criteria have been considered. We use the veto criteria. For example, some experts may have superiority in terms of experience or the knowledge in this aspect. Therefore, we can give the veto right to each expert. And we estimate the optimistic degree of the integration. This optimistic, we are going to select the alternatives which have the least distance to the optimum one and the most distance to the negative one. And based on the experts' attitudes, we may have ordered weighted average operator based on AND or and OWA integrators. Here we can have the minimum and maximum, because between and or, we may have different classes of operators, and quantified guided OWA approach will give us different classes of alternatives. Density induced OWA. And the methodology is almost same what with the previous one, but we have used the game theory and quasi-integral operators. Here, different experts' opinions will be considered, and we calculate the specifying each criteria, normalization of the criteria, calculating the statistics, and separated square error as a quasi-measure. Then we use the vulnerability map based on calculating vulnerability of the degrees of the quasi-integral. We have also used the game theory with these different indicators, and then group decision making, whether all the evidences, all the experts have the same result or the majority of them, and then we can validate the results. Contributing factors are the same as the previous research. And we have got the, based on the iteration, we got the errors, and we have considered the game theory and SPA modeling, compared both of them. And shape index have been calculated. Sorry for the Persian words. I couldn't see it. The interactions and the veto analysis, we can calculate the optimal degree based on the views of different experts, and this is the vulnerability map by the expert number 1, expert number 2, number 3, number 4, number 5, and this is the Sogino integrated method of expert number 2 for group decision making, and using a quantifier of half, it means the 50% of the experts' ideas have been used. If we may have, or most of them, for example, here is the idea of the most of the criteria in group decision making. For the validation of the results, we have used a number of validation approaches. We have used Spearman for the factors, which based on the confidence level and the number of scores. For the validation, we have compared these results with GRC and also with the TOPSIS approach, optimist and the pessimistic approach, and it gives some estimate of the results for comparison. We have also done some sensitive analysis of the approach in order to change the attribute values, model parameters, and eliminating the criteria in order to find out the importance and sensitivity of the criteria. And sensitivity analysis shows that, for example, earthquake intensity and slope has a high sensitivity in this respect, and the conclusion of different experts and data have been considered. Here also we can find out in the majority of all the criteria, most number of Tehran statistical units are at very vulnerable or medium or vulnerable, but least number of statistical units have very low vulnerability. For group decision making and different criteria, we have also done another work on integrating estimation of seismic vulnerability assessment based on rule mining of the granular computing. In this approach, GRC have been used in this flow chart. It is almost the same as the previous single GRC. In this study area, we have considered the North Tehran fault activation, Rain fault activation, and also Mosha fault activation. Data are the same. Different experts' judgment have been done. The GRC rules extracted. If the Mosha fault is activated, this is the vulnerability map. If the Rain fault is activated, this is the vulnerability map. If the North Tehran fault activated, is that. But we all know that from physics that if some wave is activated, some object is activated, it can activate the other objects around that. Therefore, the worst case scenario is based on the activation of all the three faults simultaneously. Here are the gas storage centers in Tehran, and we wanted to estimate the possibility of the vulnerability assessment, physical vulnerability, the effect of the gas centers, using the GRC and ANN approach. And this is the result of the different Mosha fault, North Tehran fault, Ray fault, and aggregation model. As the conclusion of this work, natural disasters are, especially earthquakes, are very important and impediment in our national sustainable development, because in many countries, for example, I know when the Christchurch earthquake happened in New Zealand, it takes 7% of the GDP of the country, and the same scenario may be occurred in Iran. Therefore, people have to cope with this problem. Although Professor Openshaw in 1988 mentioned that we have to cope with errors, we have to live with errors, because errors are in all the data, in all decision making, but we can do some strengthening, some precautionary measures. Urgently, we need NSPI in Iran, although the efforts have been done during the last 15 years to develop national special data infrastructure, but it's very important that one of the main impediments in our disaster management that we do not have reliable data, high-scale data, and timely data in an accessible form. Geomatic engineering is the center of disaster management cycle because a major part of the decision making models is based on the data and the reliability of this data. Quality should be validated carefully, and it's the key approach to the successfully, especially enabled society, especially enabled government. Production of data and qualification of seismic alternative map and risk maps can have a number of applications in urban planning, urban data, disaster management as a crucial proper sustainable society and economic development. And that's all for my presentation. And I would like to have some questions from the audience.
Thank you, Dr. Delavar, for the presentation, for overview and the different approaches towards this vulnerability mapping. We still have time for some questions. Yes.
My question is regarding to the validation of these approaches that you use. Of course, for validating them, you need an earthquake to see what happens. But I would like to know if the previous events, the earthquakes that already had happened, if you use this data to validate, to see if your results were okay.
So in quality assessment, we have two approaches. One of them are based on internal approach, internal assessment, and external assessment. The methodology which I've explained mostly on based on internal assessment. We have compared the results with different approaches, and in order to find out where is most likely results in different approaches. But in terms of external evaluation, we are doing right now. We are doing an analysis in Tabriz, in the city, a mega city in the northwest of Iran. And because we had an earthquake a couple of years ago from the village, some village near the city, and we are going to use this data in order to validate the possibility of the earthquake. This is the only word we can have in order to compare these results. We try to use the increase the number of experts in our analysis because different experts with different views. We have tried to use different samples of the data, increase the number of some samples. The other issue is that we try to reduce the uncertainty using different spatial data fusion methodology. But I think at the moment this is all we can do, because we are trying to give some alerts to decision maker that there are some strong possibility of earthquake and fatalities in Iran, and they can do some precautionary measures. For example, I concluded that we need MSDI in order to have access to the reliable data anywhere, at any place, for anybody, at any time. And the other issue is that when we use different data fusion methods, these have some risk, because in each data fusion method they have some assumptions for simplification of the model. Therefore, we are living in a world of uncertainty, and we have to decide in this situation that our data are uncertain and our models are uncertain. Therefore, our results could be uncertain, but we are going to reduce the uncertainty in intensity, position, location, time, and also fatalities. But your question is valid, because in this case, we either have to have the real earthquake in order to assess, or to estimate the uncertainty based on some measures.
Next question by
Yeah, thank you very much for showing us all this work which you did during the last 20 years, I guess. And you were talking quite a lot about your experts now, and I believe this is a very important work of those experts to give the proper data input for your models. Could you give us an idea, what kind of experts are these, and are these specialists in construction, or what kind of experts are these, and how much information comes from these experts?
Actually, we try to use different experts in different studies. For example, we use some seismologists, some people from tectonic civil engineering, some people from geology, some people from geophysics, some people from mining engineering, some people from these are the main experts we have used. Then in different studies we have used different samples. Every, for example, in most of them we have got something about 150 samples distributed, especially distributed in the city randomly based on stratified sampling. And then we asked them in order to estimate the vulnerability classes for these samples in different parts of Tehran, if the slope is such and such, if the floor is such and such, and the quality of the buildings. The information of the quality of building have been got from the Iranian Statistical Center. They have every 10 years, now they have every 5 years of the survey. The initial part of the estimation, we have used some satellite image in order to estimate the population distribution. But one problem is related to the views of these experts, because when we have the conflicts between different experts, we have to use some methods for conflict resolution. One risk related to this special data fusion is related to these experts' views, because we then use the same experts in all the studies. They are different. In some of them we have only one expert, but in some others we have about 5 experts. And the different experts have got different experience. This will also introduce some uncertainty. And some experts have got superiority in their own expertise. Therefore, we can, in some studies, we have weighted and ranked the different expert views. But the main point is that we try to reduce the uncertainty of this aggregation process.
First questions. I have one. How are these results transferred to politicians or to decision makers? And do you have any suggestions how to convey the results successfully?
This is a very good question, because this part is the most critical part of the research, because that part which is technical, we can easily discuss and show the results and interpret the results. But the output of this, or the providing this information to the politician is difficult, because people do not like to hear the news that, for example, there is a likely earthquake, for example, in Tehran, because we have 10 million population, and it is the largest city, for example, in Iran, and more than something around 60 to 70% of the economy of the country is concentrated in this city. It's the capital, and it's very important to have some reliable information to the politicians and decision makers. The other thing is that we have some regular meetings with different decision makers, for example, Ministry of Interior, in the municipality of Tehran, and also with different disaster management organizations during the conferences, workshops, and we try to give that, mention that this is a scientific work, and the science has the responsibility in order to clarify the decision makers and the society. But the other step, which is very important, is that when the decision makers know what to do with these results. We know that, for example, North Tehran fault is such, South Tehran fault is that, and if you are going to renew all the buildings, they are much costly, or if you are going to migrate the population, it's costly. One solution we provided is that we consider land use planning in order to distribute the people in different parts of the country and do not concentrate on some megacities, because we have about 10 megacities in Iran. And I think it is one further research on how to expose these results to the decision makers. But I think it's an initial step of the research that if we know some estimate of uncertainty, then we may have some suggestions, but how to interpret these suggestions and how to convert this into practical steps is it needs further research.
Okay.
Yeah. First of all, I like for a wonderful presentation what you have. My opinion is a bit critical. I want to know something about social aspects. Like when the earthquake or this kind of disasters happen, then your body can predict certain things. But there are also the social aspect, how the people will behave on that certain time. So that also shows how much casualty you will have, how much life you can save. So if there are anything you could what we call it, training or something like what to do on the time of very shortly. So is there anything on that part?
Yes, actually, we have started about 2 years ago to develop an early warning system for tsunami, because in the southern part of Iran, we have a Macron fault in the Oman Sea. Based on the land use planning of the next 5-year development program, we are going to have about 10 million population in the coastal areas in Iran. And in the Macron part, which is the southern part of Iran, we had a tsunami on 1955, and this tsunami was had about 4,000 fatalities reported in India, Pakistan, but no report from Iran and Oman is available. And we try to simulate the same tsunami. For example, if the same tsunami, which was about, I think about 7, there are different reports. Some reports was about 8.3 Richter. And if the same tsunami happens, for example, our Chabahar city will be along in about something about 10 minutes. The same sort of early warning system we try to develop for the earthquake, but now we are looking to get some fund from the government in order to implement this decision early warning systems. But for the awareness of the people, I think this sort of information is good mostly for the government. But if you are going to give some early warning, then we should use some real-time information and real-time modeling. That we have only one case study on the tsunami.